everyone, this is the video for Lab 6 where we will be performing spatial pattern analysis both visually and statistically. We will work on a large point dataset which includes 100,000 crime occurrences over Manhattan. So we will try to analyze and understand the patterns that are distributed or dispersed over Manhattan. Like we will try to find out the places where the occurrences were aggregated and some places where the patterns are dispersed. The data has already been provided. You can just take the Manhattan points at first, and we will try to make a fishnet over these points. The fishnet will have so many square shaped polygons, and it will cover all of these points. So this will help us to perform a kind of pattern analysis. Like we can calculate that how many points are located in the small units of these fishnet squares. So the more points will be on these fishnet square polygons, the more will be the tendency of crime occurrences. So this is one way to find out visually of where the crimes or any kind of events are aggregating. So follow these steps that I'm showing here. The cell size can be 250 by 250. And we will get the fishnet as polygons. Now we will use a tool that is a spatial join. So get the spatial join tool from here, where we will be joining the Manhattan crime points with this fishnet that we just created now. So our join feature will be the Manhattan points, and it will actually calculate the join counts for us, which simply denotes that the how many points are located in one polygon of the fishnet. So we can see that some polygons has 14 points of crime occurrences, some has 127. So the more points are situated in each of the square polygons of the fishnet, the more tendency of crime occurrences can be found over those places. So this is one way to visually identify the patterns. Simply you can also say like the hotspots of crime occurrences, even though there are other statistics to calculate the hotspots. I have had other videos on that. You can also check those in my YouTube channel. So we need to calculate the area, as well as we will calculate the crime occurrences per square kilometer. So we need to create two fields. We just can give the data type as double. After adding those fields, we can calculate the geometry. So this is a tool as well, a separate tool that also enables us to calculate the geometry. We will calculate the area in square kilometers. And after calculating the area in square kilometers, we will calculate the number of crime occurrences per square kilometer by just dividing this join count by the area that we are calculating right now. You can drag these two fields just beside joint count. It will be easier for you to navigate then. And for this you can just click on the calculate field, and from here you can divide joint count by area, and it will simply calculate you the number of crime occurrences per square kilometer of the Fishnet squares. And with this data you are going to make a map. So we are not done yet with our deliverable one. For that you have to do the same task for the census tracts over Manhattan. For that you have to copy the census tracts from the data to your geodatabase where you're currently working. Then after copying the census tracts to your geodatabase, you will perform the special join like the one you did for the fishnets. From here we will also do the same, and we'll join the Manhattan points with this census tracts. And if you uncheck this, you will be able to see the census tracts. So these are quite a kind of similar areas, some polygons showing up, which are including these points of crime occurrences inside this, like the one we did on the fishnet with using the fishnet. We can also do this using this government-based administrative boundaries like the census tracts. We are adding two more fields in its attribute table when we are done joining spatially with the census tracts with the Manhattan points. And similarly you will calculate the area in square meters and the occurrences of crime events per square kilometer of this census tract. You have to save these fields. After that you will simply calculate the geometry attributes. We will calculate the area of each of the census tract polygons, and similarly we will calculate the occurrences per square kilometer by dividing the joint count by the area. You can keep this beside one another and it will help you to navigate. When you are done calculating the crime occurrences per square kilometer, then you have to take this data and make two maps using the graduated colors symbology. Please don't forget to read this PDF thoroughly, because all the workflows, the tasks, the steps are described in very detail in here. So there is nothing that you will miss if you get through this PDF thoroughly. So don't forget to read that one to get a better idea of the instructions, the deliverables, and please don't miss any deliverables. The field for this one will be the occurrences per square kilometer, and you can give any color you want, and you can see that the darker colors are showing that this particular census tract has higher crime rate or higher crime occurrences. So this is amazing that you are able to find out patterns on this events occurring. You have to do the same for the fishnet count. And for the deliverable one, you have to make one map with this two different map frames, and you can keep this beside one another, and remember to give all the basic elements of the map as well. So we can also use this kernel density tool to find out the aggregation of these crime events. It will also help you to visually locate the particular area with higher tendency of events occurring. And as I said earlier, you have to provide one map layout with two map frames, one showing the occurrence of crime events per square kilometer from the fishnet, and another one from the census tract. That will be deliverable one. Just following this way, you can find out the kernel density, and you can see that the crime events tends to be more higher in this particular area, highlighted dark blue or violet. And I have taken a radius. It has been instructed that first you will create one kernel density map using 500 search radius and another one with 1000 search radius. Now you can see that yes, more aggregations can be found across the study area. And remember to keep your spatial analysis tool enabled, otherwise you will be shown some errors. Yes, first you have to take the 5 meter kernel density and the 100 meter kernel density. And that will be all you will need for the deliverable too. And now we will move on to the next part of this video. Like, we will now try to statistically measure which area has statistically has higher tendency of crime events occurring. Till now we were using those visual techniques. And to move on to perform a spatial autocorrelation analysis, a statistical analysis, you will need to generate the spatial weights matrix using this tool, and you have to save this spatial weights matrix file. You can just save anywhere you want. We will use this particular spatial weights matrix for our next two tasks. When we're done creating this spatial weights matrix, it's kind of weights the weighs the intensity or the tendency of aggregation of these crime events or any events over the study area. Now you're done generating it. We'll do our spatial autocorrelation analysis. We will have to provide that spatial weight matrix in here. You will get an error, but simply you can ignore it, because some parts of this study area doesn't have any neighborhoods. That's why it's saying like some census tracts doesn't have any neighborhoods, because this spatial autocorrelation is mainly calculated based on some neighborhood details and all. And when you are done doing this task of spatial autocorrelation, a .html file will generate, and if you just browse it, you will see some kind of this type of report, where it will be shown that yes, what are the statistics of spatial correlation, how is the correlation among these points, whether it is statistically significant or not, the z-score, the p-value, and so on. So this is a way to statistically find out whether this crime event has any patterns across the study area. So the last analysis that we are going to do is the cluster and outlier analysis. So you can just search this tool, and remember, we will again use the weight matrix, the spatial weight matrix that we generated earlier. The field will be the same, and we're using the census tract, and the field is this occurrences per square kilometer. And from here we have to get the spatial weight matrix file, and you can see that different colors and have been generated over the census tracts. So the black ones are saying that these census tracts doesn't have any neighborhoods, but the other colors are showing that yes, these are some clusters with high aggregation of crime events. Some has lower and some has none. So this is your another part of the deliverable, and the deliverables have been listed very clearly here. Please don't forget to provide any of these, so you're gonna miss points if you just forget to provide any of this. And very first you have to provide 2 maps, then you have to provide description upon the next tasks, and answer these questions. Similarly, at the very last, you can see that you have to give me a map of the clusters and the outliers and analysis results. Thanks for watching.